Bismillahirrahmanirrahim. My dear student, I am Dr. Muhammad Yaseen. Today we are going to discuss the part 2 of the introduction and classification of alkaloids. In case you have missed my previous lecture about introduction and classification of alkaloids, I advise you first to consult my first lecture on introduction and classification of alkaloids. In that lecture we have some definitions, basic definitions of alkaloids, and have discussed one classification method of alkaloids. So first you have to consult that lecture. After that you can proceed to this lecture. So let's move towards our topic about the introduction and classification of alkaloids. Here is the list of the key concepts that we will learn from these two lectures about the introduction and classification of alkaloids. In the first lecture we have studied some definition and function of alkaloids. We have also studied one system of classification of alkaloids. In this lecture we will discuss some other classification methods of alkaloids. We will also study the physical and chemical properties of alkaloids. Additionally, we will learn some chemical tests, how the alkaloids are tested. We will also learn how we can isolate the alkaloids from the plant sample. In addition to these, we will learn some chemical assays techniques for the identification and quantification of alkaloids in the given sample of drug. So these are the main key concepts that we are going to learn in the lecture of introduction and classification of alkaloids. People have also classified the alkaloids on the basis of the type and the nature of the heterocyclic ring. This process of classification, which is based upon the nature and the type of the heterocyclic ring, is called chemical classification. So according to the chemical classification, alkaloids are fundamentally classified into two main classes: the heterocyclic alkaloids and non-heterocyclic alkaloids. Heterocyclic alkaloids are also called the typical alkaloids. In heterocyclic alkaloids, all those alkaloids that have nitrogen present inside the heterocyclic ring, such as Yaseen and theanine, have the nitrogen in their heterocyclic ring, are classified as typical alkaloid or heterocyclic alkaloid. So the alkaloids, all those alkaloids that have nitrogen present inside the ring, are called the heterocyclic alkaloids or the typical alkaloid. Similarly, there is another class of chemical alkaloids that is called non-heterocyclic alkaloids. So according to chemical classification of alkaloids, alkaloids are classified into heterocyclic alkaloids and non-heterocyclic alkaloids. Non-heterocyclic alkaloids are those alkaloids that don't have nitrogen present inside the heterocyclic ring. The nitrogen may or may not be present outside the heterocyclic ring. These two classes are further subdivided into different classes. Let us discuss them one by one. Heterocyclic alkaloids are further subdivided into different types of alkaloids on the basis of the heterocyclic ring they possess. When the alkaloids have same type of ring structure or heterocyclic ring structure, they are classified in the same class. For example, all those heterocyclic alkaloids that have pyrrole in their heterocyclic ring structure, they are classified in the pyrrole types of alkaloids. So the pyrrole and pyrrolidine alkaloids are a type of a heterocyclic alkaloid. These are the alkaloids that contain either the pyrrole or the pyrrolidine as their heterocyclic ring structure. The example of pyrrole and pyrrolidine type alkaloid heterocyclic alkaloids is hydrogen. In the hydrogen you may see the pyrrolidine ring structure is present that I have highlighted in red color. A second type of the heterocyclic alkaloids include pyridine and piperidine containing alkaloids. These alkaloids contain either the pyridine or piperidine as the heterocyclic ring in their structure. The example of the pyridine containing alkaloids is alkaline. Alkaline is found in the betel nut or in sporine. Betel nut in our language is called as sporine. The example of piperidine containing alkaloid is the labeline. Here you may see the structure of the alkaline and labeline on this slide. Third type of heterocyclic alkaloid is the pyrrolizidine alkaloid. All the pyrrolizidine alkaloids have pyrrolizidine ring structure in their molecule. So the example of a pyrrolizidine alkaloid is semiconine. I have shown the semiconine ring structure in the red color, so you may see that the semiconine possesses a pyrrolizidine ring structure in its molecule, so it is classified as a heterocyclic alkaloid and is further subdivided into a subcategorized into a pyrrolizidine alkaloids. The fourth type of heterocyclic alkaloids include the apophyne alkaloids. Apophyne alkaloids are characterized by the possession of apophyne ring structure. The example of apophyne alkaloids include the boldine. Here in the boldine I have shown the apophyne ring structure in the red color. Since the pyrrole and pyrrolidine alkaloids contain either the pyrrole or pyrrolidine ring structure, and the pyridine and piperidine alkaloids contain either pyridine or piperidine alkaloids ring structure, so these two categories may be classified as the mononuclear heterocyclic alkaloids since they possess only one ring in their structure, so they are called mononuclear alkaloids. Those alkaloids that have a ring structure that consists of more than one ring are called polynuclear heterocyclic alkaloids. Pyrrolizidine and apophyne can be categorized as the polynuclear alkaloids. Those alkaloids that have more than one type of heterocyclic ring in their structure are classified as the polynuclear alkaloids. These include isoquinoline alkaloids, quinoline alkaloids, quinoxaline alkaloids, propane alkaloids, indole alkaloids, purine alkaloids, steroidal alkaloids, and tropinoidal alkaloids. Let us discuss them one by one. All the isoquinoline alkaloids are characterized by the possession of isoquinoline ring structure. The isoquinoline ring structure is shown on this slide. The examples of isoquinoline alkaloids include papaverine and amethine. In the structure of the papaverine, you may see the structure of the isoquinoline. Structure of the isoquinoline is present on the top portion of the structure of the papaverine. Quinoline alkaloids are characterized by the possession of a quinoline ring structure. The quinoline ring structure is shown in this slide. The example of a quinoline alkaloid include quinine. Quinine is an alkaloid whose structure is shown on this slide. You may see a quinoline ring structure is present in quinine. All those alkaloids that possess a quinoxaline ring structure as shown in this slide are classified as quinoxaline alkaloids. The example of a quinoxaline alkaloids include the vasicine. In the vasicine, you may see clearly a quinoxaline ring structure is present. All those alkaloids that possess a propane ring structure are categorized as a propane alkaloid. Example of a propane alkaloid is atropine since it contains a propane ring structure. The structure of atropine is shown on this slide. Similarly, those alkaloids that possess indole ring structure are categorized as the indole alkaloids. So the indole alkaloid is a type of heterocyclic alkaloids that possess indole ring structure. Examples of indole alkaloids include reserpine. The chemical structure of the reserpine is also shown on this slide. In the structure of Razorpan, you may see an indole ring on the top left side of the structure. A very important class of heterocyclic alkaloids include purine alkaloids. Purine alkaloids are those heterocyclic alkaloids that possess purine ring structure. Example of a purine alkaloid is caffeine. In the caffeine structure of the caffeine, you may see that the purine ring structure is present. Steroidal alkaloids are characterized by the possession of the steroidal skeleton. Example of steroidal alkaloids include solanine. Solanine is isolated or found in the plant Solanum nigrum. In the chemical structure of solanine, you can clearly see a steroidal skeleton on the top right side. Lastly, the terpenoidal alkaloids possess a terpene structure in their molecule. Examples of terpenoidal alkaloids include aconityne. The structure of aconityne is shown in this slide. All those alkaloids that possess a propane ring structure are categorized as a propane alkaloid. Example of a propane alkaloid is atropine, since it contains a propane ring structure. The structure of atropine is shown on this slide. Similarly, those alkaloids that possess indole ring structure are categorized as the indole alkaloids. So the indole alkaloid is a type of heterocyclic alkaloids that possess indole ring structure. Examples of indole alkaloids include reserpine. The chemical structure of the reserpine is also shown on this slide. In the structure of reserpine, you may see an indole ring on the top left side of the structure. There is another way to classify the alkaloids. This method of classification of alkaloids is based on the type of the amino acid which is used to derive the nitrogen and the fundamental portion of the skeleton of the alkaloid. For example, pyridine and propane alkaloids are derived from the orthanine, and hence they are called as orthanine alkaloids. Similarly, piperidine and quinolazidine and indolizidine alkaloids are derived or made or prepared from the lysine and are called the lysine alkaloids. Nicotinic acid is an amino acid that is used to form the pyridine alkaloid, and hence pyridine alkaloids are also called as the nicotinic acid. Similarly, phenylethylamine and simple tetrahydroisoquinoline alkaloids are prepared by the plants from the tyrosine amino acid, and hence they are called as tyrosine alkaloids. Simple indole, simple beta-carboline, terpenoid indole and quinoline alkaloids are prepared from the tryptophan and hence are called the tryptophan alkaloids. Similarly, histidine, the example of the histidine alkaloids are the imidazole alkaloids. All the isoquinoline alkaloids are characterized by the possession of isoquinoline ring structure. The isoquinoline ring structure is shown on this slide. The examples of isoquinoline alkaloids include papaverine and amethine. In the structure of the papaverine, you may see the structure of the isoquinoline. Structure of the isoquinoline is present on the top portion of the structure of the papaverine. Lastly, the terpenoidal alkaloids possess a terpene structure in their molecule. Examples of terpenoidal alkaloids include aconitine. The structure of aconitine is shown in this slide. If we talk about the optical activity of alkaloids, then many alkaloids are optically active due to the presence of one or more asymmetric or chiral carbon atoms in their molecule. Optical active isomers show different physiological activities. Usually the Al isomer is more active than the dextrorotatory isomer. For example, L-ephedrine or levorotatory ephedrine is 3 times more active than the dextrorotatory ephedrine. Similarly, L-ergotamine is 3 times more active than D-ergotamine. As I have already informed you that the levorotatory isomers of the alkaloids are shown enhanced biological activity are more active than the dextrorotatory isomers of alkaloids. However, there are some exceptions to this rule. For example, dextrorotatory tupochlorine is more active than the corresponding levorotatory form. Both quinine, levorotatory and the dextrorotatory quinines or quinidines are equally active. Similarly, the rhythmic dextrorotatory and levorotatory atropine is physiologically active. The fourth type of heterocyclic alkaloids include the apophyne alkaloids. Apophyne alkaloids are characterized by the possession of apophyne ring structure. The example of apophyne alkaloids include the boldine. Here in the boldine I have shown the apophyne ring structure in the red color. Since the pyrrole and pyrrolidine alkaloids contain either the pyrrole or pyrrolidine ring structure, and the pyridine and piperidine alkaloids contain either pyridine or piperidine alkaloids ring structure. So these two categories may be classified as a very important class of heterocyclic alkaloids include purine alkaloids. Purine alkaloids are those heterocyclic alkaloids that possess purine ring structure. Example of a purine alkaloid is caffeine. In the caffeine structure of the caffeine, you may see that the purine ring structure is present. As I have informed you that the majority of alkaloids show basic character. However, there are some alkaloids that are amphoteric, that is, they are acid as well as basic. The example of such alkaloids include morphine, cycloprime, and cephaline. They contain a phenolic group, and norcinine contains carboxylic group. And all the methylation of certain alkaloids can take place upon heating with mineral acids. For example, quinine and narcotine, codeine and papaverine show N or demethylation upon reaction on heating with mineral acids. In addition to carbon, hydrogen and nitrogen, most alkaloids contain oxygen in their molecules. Few alkaloids are oxygen-free, such as nicotine and quinine don't have oxygen in their structure. Majority of the alkaloids make salt with acids. Strongly basic alkaloids form salts with very weak acid. On the other hand, those alkaloids that show weak basicity require stronger acids for salt formation. Dibasic alkaloids may form two series of salts. Very weak bases form unstable salts, for example, piperine, papaverine, and narcotine, and caffeine form very unstable salts. Amphoteric alkaloids can form salts with both acids and alkalis. Alkaloids showing active character do not form salts with acid. For example, racemine do not form salts upon reacting with acid. Now let us discuss some chemical methods used for the detection of alkaloids. We are not going into the detailed discussions of these chemical methods, as these will be discussed in the later section. I have discussed these chemical methods in the structural elucidation part 1 and part 2 lectures. The most widely used method is called the Myers method for the detection of alkaloids. It is a potassium mercuric iodide solution. When a suspected sample is made to react with potassium mercuric iodide, if it contains an alkaloid, it will give the creamy white precipitate. So the formation of creamy white precipitate indicate the presence of alkaloids other than the caffeine and dilute ephedrine. Other than the caffeine and dilute ephedrine, all the alkaloids give positive malt test. The other most widely used chemical method is the Wagner method. Iodine, in the Wagner method, iodine is dissolved in potassium iodide solution. If your sample contains an alkaloid, it gives reddish brown precipitate. The third most widely used method is called the Hager's method. In the Hager's method, a saturated solution of picric acid is made to react with the suspected sample. If the sample contains any alkaloid, it gives yellow precipitate. Dragon-Dog test is another very famous test used for the detection of alkaloids. Dragon-Dog test, in the Dragon-Dog test, potassium bismuth iodide is made to react with the suspect sample. If the sample contains any alkaloid, it gives orange, reddish, brown precipitate. Mann's chemical detection method is another method used for the detection of alkaloids. In this method, potassium cadmium iodide is made to react with the suspect sample. If the suspect sample contains an alkaloid, it gives yellow precipitate. On this slide, I have discussed the method for the separation or extraction of alkaloids from the plant's material. The first step is the drying of the plant's material under shadow. Always dry the plant's material under shadow, since the drying under sunlight may evaporate or sublime some of the alkaloids present in the alkaloid material. The next step is the grinding of the plant's material. Grind the plant's material and convert it into a fine dust. Two approaches are possible. The pulverized drug is extracted with either acidified water, secondly an acidified alcohol or hydroalcoholic solution. In an acidic alcoholic or hydroalcoholic solution, the extraction is followed by a distillation under vacuum, which eliminates the alcohols and leaves behind an acidic aqueous solution of alkaloid salts. In both cases, the result is an aqueous solution of alkaloid salts requiring purification. This can be accomplished by alkalinizing the solution and extracting the base with an immiscible organic solvent, which leads back to the above step. The selectivity absorbing the alkaloids contained in the solution on an ion exchange resin, then eluting them with the strong acid. The aqueous solution of alkaloid salts can also be purified by precipitating the alkaloids as iodomercurates. The resulting solution is recovered by filtration, dissolved in a mixture of water, alcohol and acetone, and decomposed by passing it through an ion exchange resin. This technique can be used to extract the quaternary ammonium salt. Or you may use a simple technique as I have shown on this slide. First, dry the plant's material under shadow, then grind it into fine dust. Dissolve this or suspend this finely divided plant's material in petroleum ether. The purpose of the petroleum ether is to defat the plant's material. The extract will contain their fats, whereas the residue will contain the defatted plant's material containing total alkaloids and non-alkaloidal impurities. Now extract this residue with alcohol, followed by its concentration or the evaporation of the alcohol under the reduced pressure. The residue will contain the concentrated total alkaloids or non-alkaloidal impurities. Now, the concentrated alcoholic solution is then extracted with chloroform, followed by its acidification with dilute acid. Now the dilute acetic solution is extracted with an organic solvent. The organic layer is then neutralized with a weakly base such as sodium bicarbonate. Now separate the aqueous and non-aqueous layers. The acetic aqueous layer will contain the salts of the strongly basic alkalides, whereas the organic layer will contain the neutral or weakly basic alkalides or non-alkyl impurities. The acidic aqueous layer after concentration is then neutralized with ammonium hydroxide or sodium carbonate, followed by its extraction with chloroform. The organic layer will contain the chloroform layer will contain the strongly basic alkalides, whereas the basic aqueous layer will contain the quaternary ammonium bases. So this is an outline for the extraction of the alkalides from the plant's material. So the summary is, you have to use a dried plant's material, convert it into a fine dust, and then defat it with the petroleum ether, and then extract the defatted plant's material with the alcohol, followed by its concentration, then extract it with chloroform, and then acidified it with the dilute acid. Now again extract it with the chloroform. The aqueous layer will contain the quaternary ammonium bases, whereas the organic layer will contain the strongly basic alkalides. Gradient pH extraction method is another method for the extraction of alkalides. This method is suitable only if your alkalide sample or the plant sample contains the alkalides that are weakly, moderately, and strongly basic as well. So your plant sample is containing a mixture of alkalides that range in their basicity. First of all, the crude plant mixture is dissolved in 2% tartaric acid, followed by its extraction with organic solvent. The pH of the aqueous solution is gradually increased, followed by the extraction with organic solvent. The pH of the acetic solvent is gradually increased up to 9. After each increment in the pH, you have to apply the organic solvent extraction. Quantitative determination of alkaloids in the crude drug and pharmaceutical formulation is carried out with the aim of determination of genuineness of a raw vegetable material and for the evaluation of the plant material for marketing. Heterocyclic alkaloids are further subdivided into different types of alkaloids on the basis of the heterocyclic ring they possess. When the alkaloids have same type of ring structure or heterocyclic ring structure, they are classified in the same class. For example, all those heterocyclic alkaloids that have pyrrole in their heterocyclic ring structure, they are classified in the pyrrole types of alkaloids. So the pyrrole and pyrrolidine alkaloids are a type of a heterocyclic alkaloid. The estimation of alkaloids may be accomplished either volumetric method by using the volumetric method, or by using aqueous filtration method or non-aqueous filtration method, or you may also apply the gravimetric method. Colorimetric and spectrophotometric determinations are some advanced methods for the determination of the quantity of alkaloids in the plant sample. As I have informed you that the majority of alkaloids show basic character. However, there are some alkaloids that are amphoteric, that is, they are acidic as well as basic. The example of such alkaloids include margine, cycloprime, and cephaline. They contain a phenolic group, and norcinine contains carboxylic group. All those alkaloids that possess a propane ring structure are categorized as a propane alkaloid. Example of a propane alkaloid is atropine, since it contains a propane ring structure. The structure of atropine is shown on this slide. At the end of this lecture, here is a list of the recommended books. You may consult any one of the listed books for further reading.